Hi POE. So previously in our video we learned how to do centroids for basic shapes. So for semicircles, squares, rectangles, and right triangles. But what happens when we have shapes that are complex, meaning maybe they look like this? So in our PowerPoint that you have access to, we have these formulas, and boy, these formulas look way more complicated than they actually are. And really, we are only going to be dealing with this one and this one, x and y, because we're only dealing with shapes on a two-dimensional axis with height and width. We're not dealing on something that has depth, okay? So a real object in real life obviously has depth, right? Thickness. So then we would also need to use this. But for the purposes of this class, we're going to use these two formulas. Now, these look really complicated, but I'm going to walk you through the best way to do this using a table, and then it'll be pretty simple if you just fill in the table and use your calculator to multiply and divide. So basically this formula says, hey, to find the x location of this shape, we're going to take the sum of the x locations times the area of the shape divided by the sum of the areas. Okay, and to find the y location, we're going to do the sum of the y locations. That'll make sense in a second. You notice I'm being plural. Sum of the y locations times the sum of the areas, also plural, divided by the sum of the areas. Okay, so let's get to the shape, and then I'll give you an example of just a simpler one. So first, we can break the shape into three parts, right? We could break it here and here. So now we have three shapes. Okay, not too complicated. Now, you'll remember from our formula, we're going to need area, right? So we're going to do the area of these three shapes separately. And here on this slide, just as a reminder to you, we have the formula to find area of these various shapes. Okay, width and height. This could be width times height or side squared, either way. Area of a circle is pi r squared, okay? And 1/2 base times height for a right triangle. So let's go back to our shapes, okay? So area of shape 1. So shape 1 is 3 by 6, right? 3 and 3 is 6. 3 by 6 should be 18 inches squared. Area of shape 2, 1/2 base times height. Okay, so 1/2 base times height. So 3 times 3 is 9, times 1/2 is 4.5. And then here we just have 3 squared, so 9. Okay, so there we can go and fill in a table. And in a second, I'm going to show you that table. So now we need to find the centroid, though, of these shapes. Okay, so centroid is located at the intersection of the lines of symmetry. So shape 1, we're going to have a line of symmetry here down the middle and here down the middle, right? So we could say at 1.5, 1.5. So remember, we have y-axis, x-axis. So I'm going to walk out 1.5 and I'm going to go up 3. So 1.5 and 3 would be my x and y coordinate for this shape. This is 1/3 base and 1/3 height, right? It was height divided by 3 and base divided by 3. But remember, we need the coordinates. So how far do I actually have to go from here to get to here? So I have to go across 3, and then 1/3 of 3 is 1. So 3 and 1. So I have 4 as my x, and then I have to go up. So how far do I have to go up to get to here? Well, the triangle is 3 tall. It's 1/3 the height. So 1/3 of 3 is 1. So I'm going to go up 3, right? Up 3, and 1 more is 4. So 4 and 4 will be the location here. And then here, right? So this is just lines of symmetry, so half, so I'm going to go over 3, and then halfway across, so 4.5. And then how far up? Well, half of 3, so 4.5 and 1.5. Notice these dimensions are all from the 0, 0 axis, right? So this is 4 and 4. This is 3 and 1.5, 4.5 and 1.5. This is 1.5, and if we go up, 3. Okay. So now we have this nice, neat little table. And what I can tell you is your best chance of doing these types of problems is to draw these tables out. As you will see in a second, I have those tables drawn out also. Makes this so much easier to do. Okay? So, shape, well, we've numbered the shapes 1, 2, and 3. So, shape 1. The area for shape 1, right? The area of shape 1 we already calculated was base times height, so 3 times 6, 18. The x location, so the x coordinate is 1.5. And then this is just this times this. So 1.5 times 18, 27. Okay, so easy. Shape 2. Shape 2 was 1/2 base times height. So we found that that was 4.5. And the x location is 4, right? The coordinate is, I have to go across 3 and one more, 4. And then we multiply this times this to get 18. Not hard so far. Great. Area here, remember it was 3 times 3, so 9 times the x location, 4.5, right? Because I'm going to go all the way across here. That's 3 plus halfway across, 1.5. 3 plus 1.5 is 4.5. 4.5 times 9, 40.5. So we do the same thing for y. Okay. The y location of, and notice the areas stay the same, so we could just copy those from here down to here, because shape 1, shape 2, and shape 3, they all still have the same area, right? That's great. So we're going to go y, so how far up the y-axis do I have to travel? I have to go up 3, right? This was 1.5 and 3. So 3, okay, so 3 times 18, 54. No, shape 2, I had to go over 4.5, I'm sorry, over 4, and then I have to go up. So I go up 3 plus 1, so 4. And then shape 3, I have to go up 1.5. Okay. So this is where it gets really not that complicated, right? So this is the numerator of this formula. Let's go back. This formula. Sum of x's times a divided by the sum of a. Remember, sum is just adding. So now that we've got these numbers, right? So we're going to basically take, it's the sum of this times this. The sum of this times this. So the sum is just adding. Sum. So we're going to add this, this, and this. To find the sum of ai, yi, the sum, we're just going to add these 3. So that's what you see here. They just include that column. So the sum of these, 85.5. The sum of these, 85.5. That does not always happen, by the way. That just is oddly the case. And then the other part of the formula was the sum of the area. So all we're going to do is go back here, and remember these 3 are the same as these 3. So all we're going to do is choose one of these sets of area boxes, and we're going to sum them. So sum of 18, 4.5, and 9. And that's what you see here. 18, 4.5, and 9, 31.5. Now let's go back and look at our formulas. It's the sum of ai, xi divided by the sum of the area. and that'll give us our new x coordinate. For y, it's the sum of AIYI divided by the sum of the area. So in this case, amazingly, they're the same. So I go over 2.7, right? Just short of 3. So over 2.7 and up 2.7, and I get the centroid location of this shape. Really not that bad, right? Does this shape have lines of symmetry? Right? It does have one line of symmetry. Okay, so I am going to do a sample problem here. So let's do a sample problem, and I'm not going to go crazy with this sample problem. Let's do y-axis and x-axis, okay? And so we're going to have a shape like this. Okay. All right, so this is going to be our complex shape. And the first thing that we would want to do, our first step in this process, right, our first step in this process is going to be to break this into two shapes. So let's go ahead and just break it into two shapes to make it a little bit easier for us here to work with, okay? And I would just say, okay, so I got this guy here, and then I'm going to label this down here. I'm going to label this shape 1, and I can just pick, it doesn't matter, I could do it the other way, shape 1 and shape 2. So up here in my table, I only actually have two shapes. So I'm just going to put 1 and 2 in my table. Okay, so let's work on the area first. So this is 10, the base, times 7. So 70 is going to be my area up here. And so my area of shape 1 is going to be 70 inches squared. Right? Okay, and shape 2, remember, it's 1/2 base times height. So the base is 10 inches. The height of the triangle is 3, right? Because the whole thing is 10, and this part is 7. So the height is 3. So 3 times 10 is 30. 1/2 base times height. So that's going to be 15 inches squared. Okay, and then I can carry those over to here because the shapes aren't changing, so those stay the same. Okay. Okay, and then one of the things, if we remember, so in here, all this was a multiplication sign, multiplication sign, multiplication sign, multiplication sign. And then let's just go on to do a little bit of math here. So x. So the x location of this first centroid, right? So for a rectangle or a square, it's base divided by 2, height divided by 2. So the x location is going to be base divided by 2. So the x location is going to be 5. And the y location is going to be 1/2 of 7, which is 3.5, right? So that would be the centroid location would be about here for the rectangle. Okay. All right, and then we have the triangle. So the triangle, let's mark that as a right triangle. So the right triangle, if you recall, was base divided by 3, height divided by 3. So the x and y of a triangle, right? So if you remember, it's base divided by 3 and height divided by 3. And so let's do the base divided by 3. So 10 divided by 3 equals 3.33. And then y divided by 3. So we got to be careful here. So the y divided by 3. So this is 3. So this part here this part here is 3. So it's 3 divided by 3 is 1, but it's 1 plus 7, right? Because the coordinate is what we're getting here. So to get up to here, I'd have to go 7 plus 1. So I would have to go 8. Okay, 7 plus 1, I have to go 8. Okay, so the key here is this, right? Because when we did these pieces, right? When we did these equations, if you remember from the first video, what I told you for a right triangle is that when you do these equations, that the number you find has to be the distance from the right angle. It's the distance from the vertex of the right angle. So for x, we'd have to go 3.3 in towards the shape. Okay, so that's about where our location of our centroid is on the x-axis for that shape. And then our y, so remember we're going 1 in to the shape. Okay, so if our centroid is here, what is the actual coordinates of the coordinate, the x coordinate? So the x coordinate would be 10 minus 3.3, so 6.67, right? So from here to here would be 6.67, and from here to here would be 7 plus 1, 8. Okay, so that's still 8. So we're going to do 8, and here we're going to do 6.67. And then we just need to do a little multiplication. So we have 70 times 5, and that gives us 350. So the area of shape 1 times the x location of shape 1. Here we have 15 times 6.67, and we get 100.5. 100.5. 7 over here, we're going to do 70 times 3.5, and we get 245. Okay, and then here we have 15 times 8, and we have 120. All right, so if we take this and we say, all right, let's get our eraser out real quick. Okay, we get our eraser out, and we erase all this stuff off of our shape here. Okay, and we basically go back and we say, all right, so let's look at this math then that we need, right? So the math wasn't really that complicated. To find the new x and the new y, we had an equation that basically said the final x, okay, the final x is equal to okay, so the final x is going to be equal to the sum of these divided by the sum of these. Okay, so the sum of these is 350 plus 100.5. So 350 plus 100.5 is 360.5 divided by the sum of the areas, 70 plus 15, so divided by 85. So 360.5 divided by 85 is 4.24. So our new 4.24. That's the new x coordinate. And then to find the new y coordinate, we just needed to do the sum of area times that divided by the sum of the areas. So we go over here and we say, okay, the sum of these, 245 plus 120 is 365. Okay, so 365 divided by our sum of our areas stays the same because our areas are the same here as they are here. So that's going to be 85. And 365 divided by 85 is 4.29. Okay, so that's our new coordinates. Our new coordinates are 4.24 and 4.29. So if I asked you the x coordinate of the overall shape, you just found a mistake in my math, and hopefully you all already caught it. I'm sure you did. This is where you'd all be yelling out in class telling me that I made a mistake. And you know me, I'm okay with that. I added this wrong. I don't know what I was doing with my calculator, but I did something wrong, which is a good time to check things. So let me get rid of this guy here. Okay, and let's go back here. So the sum of AI xi, the sum of this, right, plus this, I think I did 350 plus 10.5 in my calculator. So 350 plus 100.5 is 450.5 divided by 85, which is 5.3. So our new coordinates are 5.3 and 4.29. Okay, 5.3. So we go across. Halfway is 5, so 5.3 is about here. And 4.29, so 3.5 would be about here. So somewhere about-ish here is our centroid of that shape. Okay, so 5.3, 4.29, and that's the final coordinates of our complex shape. Okay, so if you can master these tables, and just remember not to get confused with these equations because they really just seem more complicated than they are. Really, it's the sum of the stuff in this column. It's the sum of the stuff in this column divided by the sum of the stuff in this column divided by the sum of the stuff in this column. Okay? All right, great. So that's complex shapes, and that'll wrap it up for today.